About two types of chemical reactions. The first one called combination and the second one called decomposition. So a combination reaction is defined as a reaction with two or more reactants that produce only one product in the end. So a general example of what I mean by that is if you had reactant A plus reactant B, they would react together and produce product C. The hallmark here is that there's only one product produced at the end of this reaction. The definition of a decomposition reaction is the exact opposite. The decomposition reaction is where you have one substance, or one reactant, if you will, that produces two or more products. And the key hallmark here is the two or more products. And it would look something kind of like this. If you had substance D, that would decompose into two products, E and F. And we would typically write that as plus F. So these are actually probably the easiest types of chemical reactions to identify. So what I'm going to do is I'm going to give you several examples of reactions. I want you to use what you know now about combination and decomposition types and identify these reactions. Now each of the reactions I'm going to give you are unbalanced, so I would like for you to check to make sure that they are balanced first and then determine whether they're decomposition or combination. And once you pause the video right now and try and see if you can do this for each of these four examples. And then when you're done trying this yourself, press play and then come back and look at the answers. So for the first problems, ammonia plus hydrochloric acid to produce ammonium chloride, it is actually already balanced. So this guy is balanced. And it turns out because we have two reactants, this would be likened to A plus B, yields one product, C. So we would call this a combination. The second one is not balanced. We would need a 2 here in front of sodium chloride and a 2 in front of Na in order to balance that completely. Again, this is the same feature of A plus B yields one product, C. This would be considered a combination. The third is definitely not balanced, so we'll put a 2 in front of nickel to balance the nickel 3 oxide in the first substance. And then we would put, say, a 2 in front, a 3 in front of O2, and then maybe a 2 in front of Ni2O3, but then that unbalances our nickel over here. So then let's put a 4 here, and I think that that balances at that point. So yay, we're balanced. We check that off. This is actually the form of, say, if we have a substance D that yields E plus F. So this would be a decomposition reaction. Here we have nitrogen plus hydrogen to give you ammonia. Is this balanced? Nope, we'll put a 2 here. And then that gives us 6. We'll put a 3 here in front of hydrogen, and I think that's balanced. And again, this is forming one product here, so we'll call this combination. Let's try a few more examples. Right here I have 3 more. Again, we have P, 1 and 1, chlorines, there's 5 and 5, so this guy balances, but we're taking two or more reactants and forming one product, so we call that a combination. This next one's a little different in the sense that you have a hydrated compound as your reactant. But when we look at substances that are in the form of hydrates, this is one substance. So this is one molecule, and we treat it as such. So this would be like if you had D yields E plus F. So we would call this a decomposition reaction, and we need to check and make sure that that is balanced. And we have one copper sulfate, copper 2 sulfate on the left, and one copper 2 sulfate on the right, with each of those have 5 and 3 waters. So that means over here we'd have to have 2 waters on the right hand side to balance that out for each element. Okay, so that's now balanced. So now let's take our last particular reaction and let's look at the formation of that. This would be like having our D yields E plus F again. So we call that decomposition. And is it balanced? Definitely not. So we'll put a, let's see, we'll put a 3 here, a 2 here, put a 2 here, and that should balance us pretty good. So I think we're done with that. Okay, so again, the combination of decomposition reactions are really easy to identify. Just be able to identify them in the future and be able to balance them for sure. Okay.